Hello and welcome back. Alright, in the last set of videos we took a look at some sorting algorithms. In this set of videos we're going to take a look at graphs and trees. I think normally you usually learn trees before you learn graphs if you actually take a software or computer science course. I never really understood that because trees are really graphs. So we're going to go ahead and learn graphs first because graphs are the actual more generic and kind of the top level item. So with that, let's go ahead and learn about some graphs. All right. So what is a graph? Well, in computer science, a graph is really just a collection of what we call nodes and a collection of edges. And what that means is that it's really just a relationship between data. So our data are our nodes, and we have these ways that we connect our data to one another, and those are our edges. So our edge always connects two pieces of data together. So let's go ahead and take a look at visually what this is going to look like. So I'm going to represent my nodes with circles and give them a letter name right here. So this is going to be a node. Okay. And okay, so we have four nodes right here. Now, the way in which we draw a connection between them is just a line, and that's called an edge. Okay, and so the edge is the relationship between those two nodes. And an edge always connects two nodes. You don't have an edge that just kind of trails off into space and doesn't actually connect anything else but a single node. All right, so let's go ahead and draw a random graph here, I guess. All right, so let's talk about a few properties of graphs. So in the graph that I drew, the edge is really just denoting a relationship between A and D and A. There's no difference in this graph. You can get to D from A, and you can get to D from A going this way, or you can get to A from D going this way. This is called a non-directed graph. And you'll find that a lot of graphs are actually non-directed. But sometimes we actually want to establish a relationship in our graphs, and for that we want to actually use a directed graph. Now, why might you want to do this? Well, first let's go ahead and show what that looks like in our inner graph. If we were going to make a directed graph, we would simply, instead of drawing lines, we would draw arrows. And every edge needs to at least have one direction. But you can have two directions on an edge as well, like we have between B and C. So this means that you can go from B to C this way, or you can go from to C from B going this way. But note that you can't get to A, from A you can't get to B, because the direction right here of the arrow is flowing this way. So an example of this is if we take a look at one-way streets, for example. If we were going to make a topology or a layout of a set of streets in graph form, and we're going to use the intersections as our nodes and the streets that connect those intersections as edges, well, a one-way street is a perfect example of what a directed graph is going to look like. You can only go one way down the street, so traffic can only flow one way. So that's how we want to actually store that data in our program so that we can represent that. That's just one example. And the last property I want to talk about graphs is this concept called a cycle. So in our non-directed case here, we had a cycle. So I'm going to go ahead and draw another one. Okay. So I made this edge so that I can flow both ways, so I can create a cycle here. And so a cycle is the ability to traverse from a set of nodes back to itself. So if in this example we have B to C to A back to B. And so this creates a loop. If we were to walk this graph and try to find the end of the graph, for example, if we don't detect that there's looping going on here, we're just going to be iterating over all of our nodes, and that is not a good thing. So there can be acyclic, which is a graph with no cycles, or a cyclic graph. I think I spelled this right. So obviously you can combine acyclic or cyclic graphs with directed graphs and non-directed graphs. So that's just the basic concept. So what's another way in which we might actually use graphs? So we briefly talked about a street topology where we represent intersections and streets with nodes and edges, respectively. Another easy to think of example, or at least to grok this graph thing, is a friends network. Let's say network of friends. So if you are Facebook users, or I guess MySpace as well, or any kind of social networking site, really, there's this concept of at least a friend, and then, or there's a concept of you, and then a concept of friends, and you have that relationship between one another. So let's say we have a guy named Bob, and he has friends Joe, Sam, and Sue. All right, and then we have Sam, and he knows Sue. And then we have Joe, and Joe, he doesn't really know anybody. I'm going to go ahead and draw in the implicit relationship back to the original person. So Sam knows Bob from above, and Joe knows Bob from above. And I'm going to put that in brackets. So how does this look if we were to actually go ahead and write it out as a graph? Well, our nodes are our people, so let's draw a node for every person. So we'll put Bob here. We will put Sam in this bubble over here. And we will put Sue over here. And let's just go ahead and put Joe here. All right, so I have all 4 people. And so now I said Bob is a friend with Joe. Okay. Bob is also a friend with Sam. And Bob is a friend with Sue. And then I said Sam is friends with Sue as well. So we'll make that little connection right there. And we said Joe, he's a friend of nobody but Bob. All right, perfect. So that's actually the same picture I have above, but this is how. This is a very simplified version, but this is what a friends network would look like if there was only 4 people involved, and you could easily see the relationship between people, and you immediately know who everybody knows and who they're friends with. So that's graphs at a very high level. So in the next video, we'll go ahead and take a look at how we can implement a basic graph like this. All right, thanks.